All right. Well, thanks to Open Source Data Summit for having us here today. And thank you all for attending our talk. If you all are running Trino out there, you might find yourself saying to yourself, one Trino cluster is just not enough for me. And so if you find yourself in that state, we want to introduce you today to the Trino Gateway. You'll be hearing from me and Manfred. Manfred is a maintainer on the Trino and Trino Gateway projects. In addition to that, he's also a co-author of Trino, the Definitive Guide, which is an O'Reilly book. My name's Will. I'm a maintainer alongside Manfred, and both of us work at Starburst, which is a company that does enterprise support for and builds an enterprise product on top of Trino. So by now, I think I've said Trino about 10 times. Some of you may be wondering what that is. So I'll turn it over to Manfred to do a little bit of explanation there.
Awesome. Thank you for the introduction in this October here. Let's talk about Trino. So for those of you that are analysts working every day with SQL, Trino is what you want to use. Trino, when we have this short explanation, is a ludicrously fast open source SQL query engine designed to query large data sets from one or more data sources. So what does that mean? Well, it means that you use the SQL query language that you know and love already for querying data. You can have many of these different clients that support SQL connected to Trino, and you have also many data sources, and they're all in one analytics platform. Specifically, this means that we support many lakehouse platforms. So not only the old Hadoop Hive setups, but also like the more modern Iceberg, Delta Lake, Hudi kind of stuff, but also that you can enjoy lots of performance with this, right? Like Trino is all about performance in terms of analytics, right? So jump back for a second, Will. So Trino enables you to run these SQL queries in quite complex SQL details and stuff like that, just like you already know. But where can you run Trino? Well, you can run it anywhere, really. It's running on-prem at many customers. It runs in the cloud on Amazon, Google, or Microsoft Azure clouds, or any other cloud, really. It's up to you. And many cloud providers and other vendors also have offerings where you can run it yourself. And if you're like a bit lazy like me, you don't even want to do that, you can use a managed product like Starburst Galaxy that just wraps it all up in a nice UI and does all the management and in a great UI. But in all those cases, you can use all these data engineering tools that you know and love, right? Like from like dbeaver on the Java side to dbt on the Python side and many, many others to query all the data that lives in Trino. And all the data, that's a lot of data, right? Like I mentioned the lake or lakehouse architectures already, but it also includes many other databases. So all the relational database management systems that you know and have been using for decades, probably Oracle or PostgreSQL, MySQL, and then also other systems that are like a bit more like on the like alternative side, as they used to be called NoSQL databases and stuff like that, such as like OpenSearch or Elasticsearch. Those systems can also be queried in Trino, and specifically, they can be queried with SQL, even if that underlying system doesn't necessarily support SQL, and you can query them all at the same time, and you can move data from one to the other, all with Trino. And that's why, if you're not using Trino yet, you should.
Yeah, exactly. I strongly agree there, Manfred. So now that y'all know what Trino is, you might wonder to yourself, why would I have more than one Trino cluster? If it can connect to all these data sources, why would I ever need more than one? Um, well, there's a variety of reasons, really. You might have data in different places. You might want to keep your processing, which, Trino is a query engine at its core, close to your data. Maybe you've got some environments on-prem and some on the cloud. Uh, Maybe you've got some in different geographical locations. Maybe you have data that's in Europe, and for regulatory reasons, you have to query it and process it in Europe. And maybe you have data in Asia or North America or Latin America, and for different regulatory reasons, you have to process it there. Maybe you've got some internal politics and different groups fight over their budget and processing power, and you want to stay out of that fight and just give them their own Trino cluster. Or maybe you've decided you have different workloads and you got a fit for purpose. You know, we have Trino with a fault tolerant execution mode that can be great for very long running queries that process huge volumes of data. If you lose a node in the middle of the job, you don't want to restart it. Alternatively, we have a streaming mode, which is great for really fast analytics. If you're running Trino to serve data to an externally facing application, for example, and you get these lightning fast response times, then you would want to run that in streaming mode. So the reality is you really want to have all these different clusters potentially for all your different reasons, but you don't want to then put the burden of figuring out your architecture on your end users, right? You've got some business analyst sitting there. He's, doing some important analytics for your company. You don't want him to have to realize, this data set that I'm looking at, that's over on my Euro cluster. This one is over here on my North American cluster. You just want them to point to trino.company.net and run their queries kind of completely unaware of all the complexity that's going on there. Every cluster is going to have a different URL, but with the Trino Gateway, you can hide that. You can give people a single, simple client configuration that they can put into one of those many tools that Manfred highlighted up there. And then you can make the decision where their query goes. Just on a technical note, by the way, Trino is built on top of the HTTP protocol. So when you're doing this routing, when you're making those decisions, what you have access to is an HTTP request. You have low-level information from that request, like what's the client IP address. You have protocol information. Trino puts a lot of its protocol information into headers, like what's the identity of the client tool that fired this query. You've got semantic information as well, which is the body of the HTTP post request that initiates a query that contains SQL, and you can look at what are the data objects that people are accessing. So I'll turn it over to Manfred to talk about what is this Trino Gateway.
Yeah, so users, in fact, can even like sort of customize a bit more on what's in that payload when it comes to the Trino cluster. Also, I wanted to mention Trino cluster. One of the things why Trino is so fast is because it is a cluster. What that means is there's not just one server that runs, but there is one main server called the coordinator, and then there's many workers. So there's like some people have like 10, 20, some people have 100 or more nodes in one cluster to allow them to perform operations such as reading files from S3 in parallel, right? So Trino is also known as a massively parallel processing engine. So you typically have like hundreds of servers involved in these kind of like deployments. And all these servers are the Trino clusters. But for the user, they don't want to know about that, right? Like there's like, for example, a person that writes some queries manually, and they just want to connect to the Trino Gateway. And that Trino Gateway is like a load balancer / proxy server. And it's also configurable as a routing gateway to determine that, for example, that query that comes from that automated tool that does some billing analysis and creates a new dashboard every night, that goes to a different Trino cluster, and it does all that routing automatically. And the business analyst that sits there and types away on their queries and does like that, they don't want to have to worry, and also not worry about switching the URL of those Trino clusters, right? Like Trino clusters get updated all the time, and you don't want to have to tell your users, and especially if there's many, and many organizations have hundreds of analysts working on Trino, you don't want to have to tell those 100 people or more that they have to change like the URL in their server because you upgraded to the next version. That's a waste of time of everyone. So Trino Gateway allows you to switch this around transparently.
Yeah, so a quick overview of the open source side of this project. It was originally put out there into the open source by Lyft, which time it was called the Presto Gateway, which is an older name for the Trino project. The modern version of the project that we're all contributing on now first contributed to open source by Bloomberg, which indirectly came to them from Lyft back in July 23. And we presented it at our own Trino Summit around that time, a few months after it was first contributed. We've got a really active team of maintainers and contributors on this sub-project of the larger Trino DB project. And among the Trino user base, we've seen really a huge level of adoption. We have a lot of really active Trino users out there that are using Trino at large scale in their own enterprises. And they're really kind of driving the adoption usage of this project. We do a public developer sync every 2 weeks. Everybody is welcome. We're up well over 400 commits right now since this project was started, and I feel like we'll probably hit 500 pretty soon. And just released number 11, I believe, a week or two ago.
Yeah, and it's probably another week away until we get 12 out. So we are very proud to have this active community and work with people from around the globe and many different companies, right? Like these companies all had their own versions of Presto Gateway, and we're just pulling the strings together, and like as a pure, really good community effort, we're making these use cases satisfiable for everyone. The simplest and very important use case for Trino is high availability. Everyone is always like, well, I don't really want to reboot my cluster because I'm added a new catalog, or I need to do an upgrade of Trino. Well, with Trino Gateway, you can hide those details of necessary restarts and so on from your users. All you have to do is essentially you have more than one cluster behind Trino Gateway. And if they're identical, then Trino Gateway can random routing that's built in, just direct queries a little bit to that cluster and a little bit to that cluster. So even distribution between the two clusters in terms of load. And then if one of the clusters ends up dying, the Trino Gateway finds out about it immediately, and the users won't be affected at all because it will just route to only the cluster that's alive. So very easy to get that going. It's basically our default deployment with Trino Gateway.
Yep. A slightly more elaborate use case, we've gone past simple high availability now, is the blue-green deployment style. So with a blue-green deployment, this is something that you might do when you do an upgrade or a configuration change, and you want to gracefully do this without downtime. The kind of methodology here is initially you start with an even distribution of queries between your blue and your green clusters. Then you first drain the blue cluster, which you do in the Trino Gateway very simply by just pressing a single button, which says change this cluster to the inactive state. That means no new queries get sent there. All the running queries continue until they have completed. You can see the number of queries running in the UI. And so you can tell when your drain is done, when all the entire workload has been switched over to the green cluster. You take blue offline, you upgrade it, you test it, you bring it back online. Then you sort of reverse the process. Drain green, shift the workload back to blue, upgrade green, bring it back online, and then you're back to an even distribution. If you're running in the cloud, by the way, you can do things like scale up these clusters during this process so that you don't give your clusters or your end users any kind of degraded performance during the operation. You can also take advantage of all the logic that's available for smart routing within the gateway to do more sophisticated upgrade methods like the canary method.
Yeah, the world is sort of your oyster. You really have a choice on how you do this. And Trino Gateway makes it very easy because it exposes a lot of that info in the user interface. Obviously not available to everyone, but to administrators only. But that makes it very easy to do. And then what happens on the management of the clusters behind Trino Gateway depends totally on the deployment. And in fact, you could use Starburst Galaxy to just do it super easily, or you could like manage your own Trino on-prem with whatever, where you like update on Kubernetes or even with virtual machines or something like that. So very powerful.
You can totally mix and match too, I should say. This gateway is really agnostic as to the flavor of Trino that you're running. You could run a mix of open source Trino, Starburst Enterprise, our SaaS offering, one of the Trinos offered by one of your hyperscaler cloud providers, kind of all up to you. And you can use this feature, this smart routing feature, to decide who goes where. So as I mentioned before, you're often going to have different users that for one reason or another have to hit a different cluster based on their identity or what they're doing. There's kind of two different levels of routing that happen. Primarily so far, we've discussed load balancing, which is where you have a set of logically identical clusters and you're just distributing work among those. Manfred talked about the random routing, which really stochastically just picks a cluster out of a hat, rolls a dice. We can also do active load balancing. We basically look at which cluster is running the fewest queries, has the lowest load currently, and send a query to that cluster with the lowest load. Besides this load balancing type strategy, there's also logical routing. And again, this is where you're going to pick apart that request and decide based on that what cluster is a best fit for this piece of work. The way you configure that, there's really two different methods there. One is you can upload a file to the gateway that has a set of rules. These rules are basically authored in a Java-like language. So, you have really a lot of power in terms of the expressions that you have access to, pretty much anything you can do in Java, which is pretty much anything, right? If that's not enough for you, you can also make a REST request to an external service and put whatever kind of custom logic you want in there. You could sprinkle in some machine learning fairy dust in there to magically pick the correct cluster every time. You can call out to an external service to get more information about this user. Are they on the naughty list, or are they, do you want to send them to the executive cluster? Really, whatever you need to do.
Also important to mention is that once a user files a query, that query gets processed by that one cluster. So it's all in that one cluster, but then the next query they send is like a new request, and it could be routed to a different cluster or a different, like completely different cluster, depending on the workload and that metadata in the request, even for the same user.
Yep.
So how do you
Yeah.
get Trino Gateway running, Will?
So there's a few different options. And again, we're trying to make it easy depending on sort of what kind of setup you have. What you're going to see in a moment when I do the demo is that you can run this thing locally just using a jar, an executable jar file. You can do a more sophisticated setup in Kubernetes. We have a Helm chart and a Docker container that's up on Docker Hub that you can pull and use to get started. Trino Gateway itself is stateless. It's a web server basically, so you can run one instance or you can run 100 instances and load balance among those with a pure load balancer like a cloud load balancer or an F5 on-prem. The state is stored inside of a relational database. We support both MySQL and Postgres currently. And if you take a look at the GitHub project, you're going to see a quick start guide. Is basically runnable from your IDE to get things set up. All you really need to have installed is Docker. There's also a Java runner that you can execute within your IDE for local testing. And this thing is configured conveniently, in my opinion, anyways, with one big YAML file. So
I'm
there's
sure not everyone shares that opinion. Some people are not so much in love with YAML files, but it is what it is. It's a good file format to cram a lot of information in, and that's what we need.
Yep. At least you don't have to chase around a bunch of different properties files. But yeah.
That is true.
All right. So we've made it all the way to our demo. So first thing we're going to look at, as I mentioned, I've got Trino Gateway running here on localhost. And what you're seeing right here is the clusters panel, which gives you as the admin an overview of all the different backend clusters that you have attached. I should note, this is a local demo, so I don't have any security configured. You can lock down all aspects of this UI and the API. You can use OAuth or LDAP to log in. So all that is enterprise level, well supported. So what do you see in this screen? You see a couple of key details about these backend clusters. One, we give them a unique name and then a routing group. This routing group is going to be the target of one of those logical rules. Ad hoc is the default routing group, and I've also have a special one that I've designated for my ETL queries here. So when I've got my routing rules, I'm going to pick this ETL for specific queries. Then I just see the address of my backend cluster. I can check real quickly here that I've got nothing running on this one. Again, just local. But that's the open source Trino UI right there. And we can see there again is nothing running. And then this active state right here, this is what tells the Trino Gateway whether or not a cluster is available to send queries to or not. So if I were to do a drain, if I wanted to do, say, a blue-green upgrade, all I would have to do is click this button right here. This means no new queries are going to go to Trino 1. Everything that goes to ad hoc will go to Trino 0 until I turn this thing green again. So
that's pretty simple, isn't it, Will?
yeah, not much to it. I mean, it's a lot simpler than trying to do the same thing with a cloud load balancer and setting affinities and all that good stuff. So I like it for sure. So let's run some queries to get started right here. This is dbeaver for those of you that don't recognize it. I think I have to press this again. All right, there we go. You can see that my results all came back as expected. And now if I switch over, I can see right here, this line just popped up showing me I was inactive for a while, just ran these again. I get 5 queries. How many did I run? 1 through 10. So I actually got 5 queries, 5 each on Trino 1 and Trino 0. I'll take a moment to say I'm using the active load balancing strategy in this gateway. So this is a deterministically going to put a query on Trino 0, then a query on Trino 1, then a query on Trino 0 again. Since these are such quick queries, they all execute almost immediately. Now let's take a look at the smart routing capability. So if I switch my client here over to Python, I've set up one simple logical routing rule, which is if I take a look at the X-Trino source header, which all the Trino clients basically populate this header with their identity. If I see the Trino Python client in that header, then I want to send it to my ETL group. So let's see that in action right here. Let me run a couple of these.
And of course, that header is typically default set by whatever client you're using, but you can also custom set that to any application. So if you have a script like a CLI script that runs a query, you can set what that is into the header, and you can also add other information to the request like tags and whatever else. So there's a lot of information that can be used for that routing. This is just a very simple but handy example.
I noticed that a few of my queries failed because right before this, I had to reboot my laptop, and it looks like I forgot to start up a couple of components in my local environment. But
the gateway saved you already.
That's all right, because although the queries fail, we can still see how they got routed. If I just switch back right here, now I see that there was a couple of queries sent to my Trino ETL cluster. Those are the ones that just came from my Python client right there. And we can see, as expected, Trino Gateway noticed that they were being sent from a client that's often used for ETL, and so sent them to my special cluster right here. If I get rid of this filter, I can see that again, just see the details right here. If I wanted to check on that, then I can open up my my link to my cluster UI and sort of see the status and see what happened. I got a Hive Metastore error, unfortunately, but still decent enough for illustration purposes. All right, so that concludes the demo right here. I'm going to put this back in presentation mode for the final words.
Yeah, so that was awesome, Will. Great demo. Very simple, really, in terms of what you've written there and the rules, and that's often totally sufficient, right? Like many users, like we saw in our first use case, you don't even need any of these rules. You just rely on the query count and the stochastic distribution, and you're ready to go. But you can take it to any level of complexity, and we have users that do all sorts of things with including all the way of writing external services that make very fancy decisions. And so you see that really, if you are using multiple Trino clusters, and I hope you're a Trino user, and I hope you're using multiple clusters, you should also want to look at Trino Gateway. And we've come a long way. The project has done very big refactorings as compared to what was there from the old Presto Gateway. Many years of sort of not maintenance were overcome, and lots of new features, including the fancy new UI, were added. And so we are very proud of what we've done so far, but also we know we got a lot of big ideas and we want to do a lot more. So for that, we would want to hear from you as a user. Check out the website on TrinoDB/Trino Gateway on GitHub, or also the source code also on Trino Gateway. And of course, you can chat to us and find us regularly on the Trino Gateway and Trino Gateway Dev Slack channels on the Trino Slack. We are always available there. And we also, like mentioned, we have these developer things every 2 weeks where you can even join us for a chat about what you want to contribute and what you want to work on and get added to the feature. It's a great application that makes it easier for your users and all your data engineers that want to write SQL and not have to worry about what tool processes and the query for them.
Yeah. So I just want to say thanks again to Open Source Data Summit for having us here. And I hope to meet a few new folks in Slack or elsewhere that heard of us from this talk right here. And good luck to all of you.